Hi there! This here next to me is an Olivetti M20 computer. And this project has actually been several years coming, and to give you a little bit of context, it goes back to a fascination I had, a brief fascination about 3+ years ago with the Z8000 CPU, a 16-bit CPU by Zilog. And what fascinated me about it was that the chip was kind of a dead end. It just really didn't go anywhere. You know, the Z80 was a very, very popular 8-bit chip used in a bunch of very, very cheap computers at the time. Then the company went 16-bit. They came out with this Z8000. And other than this Olivetti M20, I don't know that there was another commercially successful computer that actually used that CPU. If someone does know of something, please let me know. There were a few obscure add-on cards, like something called the Trump card, which was a Z8000 coprocessor for an IBM PC. I've got a video on that. But that and this computer are really the only two successes that I'm aware of. And I don't even know just how successful this thing here was. I mean, certainly it seems to have been successful in Europe, but right now these things are very hard to get. So anyhow, weird dead-end turns in history, they kind of interest me, so I decided to start building things about 3 years ago using that Z8000 CPU. Not a whole lot out there to go from, but I did create something that I called the Clover computer, which was this little modular computer. I can point you to some videos on that. Used the Z8000 CPU, ran CPM 8000, had some fun with that. I upgraded my Heathkit H8 to do a Z8000 CPU. Completely impractical because there's no software for it, but nevertheless a fun project. But I couldn't get my hands on an actual M20. But then my friend Salvatore, who I've worked on with some Z8000 projects before, he told me that he knew a guy in France. And this guy in France, he had recently helped him set up some disks to try out his M20, and that guy wanted to sell that computer. And long story short, this is that computer. We wised up. We didn't send it through, postal mail. We sent it through DHL. That cost me a little bit. Okay, here we have yet another old computer. This one came all the way from France. Let's see what's in it. Okay, let's take it apart. So I've already pulled a couple of screws out of the back, and once you've done that, it simply pulls up like that. Top comes right off. Okay, one of the things I want to do is to update the M20 to have more memory. Now this should be a relatively straightforward procedure. I have some small memory boards here. But one of the things you have to do is you have to modify a bunch of jumpers on the motherboard to do this, and that's actually a little bit involved. So I've taken the case apart. We'll take this plastic piece off. Might as well pull the keyboard and get it out of the way. And then we need to remove the drive assembly, because the jumpers on this variant of the motherboard are beneath the drive assembly. So pull the two Molexes, get them well out of the way. And then you can reach down, you can unhook the floppy connector. And now to remove the drives, you need to slide forward and pull up. So, and this might be kind of stuck in your M20 because, could be, 20, 30 years. But move the drive assembly forward. And out it comes. Okay, now we can see a lot of things. So first of all, I don't know that I've talked about this, but I did replace the fan. Fan is a 12-volt Noctua, and it's hooked into the 12-volt line on that cable. We can see our ROMs up here. I've already replaced these with some version 2.0 ROMs that I got from Salvatore. We can see the RAM chips. The stock ones are here. This is a revision D motherboard. You can tell that because the ROMs are over here. The revision G has them kind of in the middle. You've got 2 expansion slots for general purpose expansion boards, and then 3 slots for memory. Okay, here is the memory expansion board. This is a 128 kilobyte memory expansion. My buddy Salvatore sent these to me as bare boards. I populated the chips on them. They have four DRAM ICs. They are 41464, which are 64K by 4 bits. If you put 4 of those, you'll get 128 kilobytes. Now the computer can take up to 3 of these boards, plus the 128 kilobytes on the motherboard will get you a total of 512 kilobytes. Okay, the first thing to do is to remove U62 through U65, which should be these socketed chips here. And these are the decoding logic for the 16K banks. And then it wants us to install jumpers along there. That's a bunch of jumpers here, should be like 8 of them. Now we need to find K and move it from K2 to K1. This one here is K, he's on K2, we'll move him to K1. We need to find V and move it from V1 to V2. This is V right here, he's on V1. Move him to V2. Then W needs to go from W2 to W1. This one here is W. He's on W2. Move him to W1. Next one is M. Going to move M from M1 to M2. Here's M. It's on M1. Move him to M2. Now we need to take X, which is over here, and there's a jumper on X2 to X7. It wants us to move it to X1, X2. Okay. Now at this point our computer won't boot anymore because it will now require at least one expansion board installed in it. So this board here is a compact flash / IDE board. Salvatore also sent me this one. I think he also gave me the pre-programmed CPLD device there that went with it. And what it does is it allows you to hook a compact flash card. I've got one of those mounted in a socket on here on the back. Or a disc on module, like this hyperdisk one here. Plug into that socket. You know, you might want to use like a right angle there, it'd be more convenient. Or this little 44-pin disc on module, kind of plug in like that. But use any of those and it will simulate a hard drive in the computer. So you can have a hard drive that's much more convenient than the floppy drives. Now I have run into some compatibility issues with this. Some of my compact flash cards did not work, some did. This particular one here did. I buy these on Amazon, these 256 megabyte. But some other ones like my 64 megabyte Cisco cards, they wouldn't work in here, it just wasn't reliable. Same thing with the disc on modules. Some of them work, some of them don't. And even this disc on module which Salvatore sent me, which these work fine for him, I couldn't get this one to work for me, so I was kind of surprised by that. We speculated maybe it had to do with some of the chips, you know, was it HCT versus LS? Don't know, we really didn't get to the bottom of why some devices are working and some are not. I believe he did design this to take a few additional things like a real-time clock. That's not populated, but it's a nice simple board and it will give your M20 hard drive capability. Okay, the next thing I'm going to do is to remap the keyboard into something that's a little bit more convenient for me. So this computer, having come from France, has what is known as the AZERTY keyboard. Instead of a QWERTY, it's got AZERTY. Not the most convenient thing for me to deal with. The Q is down here, the A is up there, the W is there, the Z is there. One thing about this Olivetti is it is possible to fully remap these keys in software. So the boot disk I got from my friend Salvatore, it took this keyboard, it automatically came up in English. But there's also some jumpers on the bottom of the board that are supposed to configure the board to a particular language. So I'm going to try changing those jumpers as well. The keyboard is upside down, so I took it, I flipped it over and stuck it upside down here so we can get a look at it. And these 4 links right here control the keyboard's language. And you can see this one has been removed, and these settings are for a French keyboard. For a US keyboard, what I'm going to have to do is I'm going to have to solder across this one, close that one back up, and then cut this one next to it. And all of those settings are inside the service manual to tell you how to do that. So we'll go see if I can relink this one and cut that one without having to actually take the keyboard apart. Now, I also have to deal with the legends on the keys, which are wrong. Even if you remap them, they still say the wrong things on them. So what I have here is an AT&T 6300 keyboard. Maybe there's a part number on the back of it. KBD 301. Weird plug on it. But I think, I'm not certain, but I think the keys are compatible with one to the other. So I'm going to try pulling these ones off, putting them on here. We'll see what that ends up looking like. Okay, the deed is done. How does it look? I've replaced all these white keys are the ones that came off the 6300 keyboard. The only one I wasn't able to do was this one right here. And that is because the one on the 6300 keyboard, it has this part that sticks out a little bit from it. So it just wouldn't fit there next to the S1. You could take the S1 out, but I wanted to keep the S1. Now this 6300 keyboard that I used as a donor for the keycaps, I was impressed with this. This thing is pristine. This thing's like almost unused. I see not a speck of dirt in it. So I'm going to keep this in case I ever get a 6300, and then I can put the keycaps back on it. Even after doing all this, it's not quite right with the default mapping, because the Olivetti US keyboard had different settings for some of these symbols on the numbers and for some of the symbols over here. And the brackets, some of these things are moved around a little bit. Bottom row symbols are all fine, like the question mark and the pointy brackets and the comma and the period. But just a couple of these ones and this are still wrong. So I'm going to have to take and remap those in software to get them right. Now, if someone out there does have an Olivetti M20 English US keyboard, I would love to have, original one with the original keys for a US user. Put it in here. That'd be awesome to do that. So if someone has one of those, you'd like to sell it, let me know. Okay, let's go ahead and boot it up. So we have installed the 3 128 kilobyte memory modules and the compact flash drive. So I'm going to turn it on. It's going to boot up. It'll display this little dot in the corner up here. That is the memory test. That's what it writes to video RAM while it's memory testing. And it takes it a little while to do the memory test. It's longer the more RAM you have. So here we go. So 464 kilobytes free out of a total of 512 kilobytes. And we've got some room for basic. We've got a black and white display. One drive is ready. That is the compact flash drive that is ready. And this runs an operating system called Olivetti PCOS, which I believe stands for the Professional Computer Operating System. The commands are really weird for someone who is used to like DOS or CP/M or Linux. So like VQ is how you get a quick list of your volume. This is the compact flash drive, so it goes by pretty quick. We can read it pretty fast. There's a lot of files on it. VL is a long listing, and it will pause. I think there's a switch you can give it that will tell it not to do this pausing every screen. Otherwise, you're going to have to sit here and hit the key each time. So here on the compact flash, we have used what, about 5470 allocated sectors out of must be around 33,000 sectors total. Got plenty of space left. FL will list a file. So let me list out say demo.f. That is one of my fourth programs, so you can list it out. It does come with basic, 32K free. This is M20 basic 8000 print. And let's do it with for loop. Yep, screwed that up, didn't we? 20, next. Let's list it, make sure we got it right. Yep, your basic. Now I've also ported over a fourth interpreter. The one that I ported is called LB fourth, which is based on Jones fourth. I found it on the internet, and I ported it over here so that we can do fourth programming, because it's kind of my new thing lately. So load up LB fourth. Takes it a while to initialize because it actually has a text file built into the binary that lists a bunch of fourth, and it compiles that rather than having that pre-compiled. You can get a dictionary of the words. Oops. Words. Oh, come on. Words. Those are the various words that are built in. So I took LB fourth and I extended it. I added a few additional ones that I wanted. Let's see. So one of the things I have done is the ability to show a directory and to show a file. Now to show a file, so because this is fourth, if you're not familiar with fourth, it's a stack-based language. You generally put something on the stack before you use it. So we'll put a string on the stack, and it will be brute prime.f, and we'll put that on the stack, and then we'll call show file on it. And there is the fourth program that is going to do my little prime number algorithm. So I tend to use brute prime, the world's worst prime number generator. It doesn't even get the answer right. I tend to use it as my benchmark because I have it written in BASIC, I have it written in a few assemblies in C, now it's written in fourth. Fourth, the way the language works is you're constantly defining words. So we define a word called banner. We have a word called check, which checks to see if a number is prime. And then we have brute prime, which calls the banner word, and then it does a do loop where it's going to go through the first 255 prime numbers, checking each one of them. So let's go ahead and run that. Sorry, we have to load. So what I did here is I listed the file. I actually have another word here to load the file. So we need to call read file. And what this does is it just redirects standard input for a while to read the bytes out of the file instead of from the keyboard. So you'll see the little OK prompts as it loads each line. Now, we can do brute prime. I don't know why we got an unknown word there. Maybe there's just some junk me typing someplace. Anyway, brute prime, the world's worst prime number generator, as well as my website address. Why I take credit for this thing, I don't know. The reason I like it is because it spits out the prime numbers slowly to the screen, and you can easily split screen it with another implementation or another architecture, another computer, and it's, you know, it's super obvious how much faster or slower it is running. This particular one here I have set to only go up to the first 255 prime numbers, and it actually gets slower as it runs. As I said, it is the world's worst prime number generator. Now, fourth is actually a pretty efficient language, but this is fourth written in C and compiled with a C compiler, not fourth written in native Z8000 assembly. So it's a lot slower than a native written fourth might be. And just to give you an example, not a perfect example, but I also wrote Brute Prime in C using the Z8000 GCC compiler by Chris Grossler, and we can run Brute Prime. Yep. We have to give it a number. Let's try that again. And you know, the C implementation, it's much faster than the fourth implementation. And the fourth implementation, I think, would be about as much, again, faster than the basic implementation. Now, another thing I wanted to do was to get a serial console on this. Now, the computer, it actually has a card edge connector that comes out the back. We're looking at the very back of the computer. It has a card edge connector that comes out the back, which you can use for serial, but that's not very convenient. So what I did is I took a DB9, or actually a DE9, I think is what they call them, mounted it to this spot here, and I wired it up to some of the jumpers here that feed that connector. So these are just little wire jumpers. Unfortunately, they're not the kind you can plug in. They're not headers. It's just a little bent over piece of wire. So if you're real careful, because you don't want the thing actually to come out, but if you're real careful, you can just tack solder onto these wires, and you can wire up the RX, the TX, and the CTS and RTS. And that's what I've done. I'll see if I can produce a chart of which wires I hooked up to where on that, so that you can know how to do that. And that's just a lot more convenient, because then we can just take, you know, just a USB serial dongle, plug it into the back, and we can get a serial console on the thing. Now for ground, this little black wire, you have to have a ground to your serial port. I wired it up to just one of these header pins I found on this jumper block. Happened to be a ground. I think it's for either CTS or RTS. It has an option to ground it, to turn it always on. So I managed to just use that spot on the header, because it was ground, as the ground for my connector. So there we have it, and that gives us our serial. Now let me show you a little bit about hooking this thing up to the serial port. So I'm going to run basic, and I just want to do this because I want to load a file. stty.bas. So this happens to be, when you save something, it tokenizes it. So I can't just list this file out to the console, but I can load it into BASIC. I can list it here. And this is my script that is going to set up the COM port. So I couldn't find like a batch script or a bash script or any of the things that I usually find on my Linux or DOS or even CP/M. But I did find that you can write a BASIC program to execute system commands. So each one of these execs is running something from the operating system. So we're going to load the RS-232 driver, set up the COM port to use 19200 baud, open the COM port, and then this down here is like a device redirection, which is kind of unique to this PCOS, the way it does it with the plus and the minus sign. But this takes the console and adds the serial port to it. So this is going to take what is normally going to the console and also send it to the serial port. And let's back out of this. From a fresh boot, I'm going to try this. I'm going to run that STTY program. And there we go. We see it popped up over here on my serial console. And now anytime I type anything over here, it goes to the Olivetti M20. And this is fantastic for, you know, working from your DOS or your Linux or your Windows or your Mac computer, and you want to copy paste things in and do it from maybe a little more friendlier environment than using the console directly. This is great for that. But the other thing it's really great for is sending and receiving files. So let's do, I took and I ported an Xmodem implementation that I found on the internet. So let's Xmodem R, I'm just going to receive a file, I'll just call it junk. And that'll load the Xmodem sender. Let's transfer, send to Xmodem. This is right from my terminal program, and I'll send, I don't know, Conway's Game of Life. There we go. And it has sent the file. And that is one of the challenges with this computer, is getting files transferred to and from your primary computer, because you're going to want to try out some source that you download from the internet. And using X modem is a great way to do that. I have ported over an X modem receiver, an X modem sender, and a Y modem receiver, and you can just send files directly from your terminal program. That's one way to get stuff over here. Okay, now another thing I have done is I ported Zork to this. I've called it Zork. And this was originally called Mojo Zork, the Z machine engine that's used. I ported it a while ago to my Z8000 Clover computer, and it was called Z8K Zork. Then I took that and I ported it to the Olivetti. So let's try running Zork. It's going to take a while to load because it reads the whole data file into memory. There we go. Originally written by Ryan C. Gordon, ported by me. You are west of house, so open mailbox. He's still attacking me. Give troll leaflet. Ah, there we go. We have died in Zork. That's what I do on every computer, is I find a way to die in Zork. Mission accomplished. Okay, here is the alternate processor board. So this was another bare board that Salvatore sent me. You do have to go out and you have to find an 8086 CPU. And the advantage of this board was that if you use this, you could run DOS software using a variant of DOS 2.0 on the M20, which there was a lot of DOS software at the time. So this would open up a whole new avenue of software for you. So it's got the CPU, it's got, this is a 16-bit CPU. It's not the 8088, it's the 8086. So 16-bit CPU means you've got a couple of 8-bit ROM chips, so it has its ROM to bootstrap it. You've also got clock generator chip in there, clock, and a lot of glue stuff in here, like buffers going back and forth to the bus. Okay, let's try out the alternate processor board. Turning it on. As usual, we have to do the memory check. And it's going to prompt us, as long as the APB is installed, it'll always prompt us to say select alternate CPU. And if you hit no, it'll just boot PCOS. But if you hit yes, then it does this secondary check. And I'm assuming this is x86 code that we're running now on the 8086 CPU. So we're testing that all the peripherals work from the 8086. It does not apparently support the hard drive. So we'll need to put in a floppy. Olivetti had a DOS 2.0 distribution, so we'll put that floppy in. And there, it's detected the diskette. MS-DOS version 2.00, monochrome. And it wants the date and time. And you notice it's got this con IO driver, so it's got some kind of a driver that's doing the console IO. And then, we're in good old familiar DOS. With a lot of our usual files that we're familiar with. It's interesting, there's these E0 and F0 binaries. It looks like 128K of something that is going to load into the E0 and F0 segments, I'm guessing. Be fun to poke around in there and see what exactly those are. It does have a BASIC, but it is not Microsoft BASIC or BASIC A. It is something else. It is BASIC 86, also by Microsoft, but unfortunately not compatible with your BASIC A programs that you might usually run on a PC. So you can run things that are DOS text programs only on this. This computer doesn't have a PC compatible display adapter. It doesn't have a CGA or an MDA or anything like that. It's emulating that through a console driver. So only things that are outputting text and maybe some color. If we had a color display, it would handle that. So that really limits your software selection. But I do have, because Zork was so fun to do already, I have Zork for the IBM PC. And this is the actual disk from Infocom. This isn't something I have ported. This is Infocom's Zork game, and I believe this is, you know, if you look at story.com, it's only about 11K in size. So I think this is, it's probably an assembly implementation of the Z machine. So it's faster than that Z8000 one I showed before, which is written in C and compiled. So it's going to take a little bit here to load its file. Lots of grinding on the floppy drive there as it's seeking around and loading stuff from it. And there we go, Zork, the Great Underground Empire. And then, you know, like I say, a little bit faster, and it's got the little status bar up at the top that it does. Okay. And, you know, this is, so this would have been a pretty big deal if you'd had one of these computers back in the day, I think, because the amount of software for PCOS and on the Z8000 CPU is probably pretty limited. So if you could put an x86 CPU in your M20, potentially open up a whole bunch more software. Not only maybe some simple basic games and such, but also maybe some application software. Like I have to wonder if there was early versions of Lotus 123 or VisiCalc or WordStar or whatever you might have used in text mode back then. There were probably some programs that worked right out of the box with this. Now, if you'd have tried something like King's Quest wouldn't have worked at all because, again, no CGA adapter. This is not PC compatible hardware. This is a PC compatible CPU. It's the x86, but with a whole bunch of weird hardware devices and a console I/O driver written to actually make those devices work. And this here is a VGA adapter. This is another one that Salvatore sent me. He sent it just like this, you know, with the FPGA, but not with the two DRAM chips or some of the other stuff. And what this does is it implements a VGA adapter for the M20. Now somehow you're going to probably have to disable the onboard video. I'm sure he's given me instructions. I haven't tried it yet. And this was going to be my go-to device if I did not have a monitor. Because originally when I got the first M20 I got my hands on and was ordering would not have come with a monitor. And I was going to have to do VGA or MC to VGA or something to do that. So Salvatore sent me this thing. I was going to try it out. I didn't need it, so I haven't built it out yet, but people should be aware that it exists. Okay, and here's a board that I designed. This is a speech synthesizer board. Almost without fail, when I get a new vintage computer, the first thing I design for it is a speech synthesizer. And one of the reasons I do that is it's a very simple design. Usually it's just a single input port and a single output port, an SPO256A-AL2 speech synthesizer chip. Radio Shack used to sell those back in the day. You can still find them occasionally on eBay for not super ridiculous prices. So you got the speech synthesizer. I've got a couple of PLDs. Now we need to do 16-bit address decoding on the port. So I had to actually add a second PLD to decode all of those 16 bits of address space. And then there's another PLD here, just kind of like the bus signal controller to do the reads and the writes at the right time. Anyway, this will all be up on the website, the PLD files, the Gerbers, the schematics, all of it in case you want to build one of these things. So we've got the address decode, you've got the speech synthesizer crystal for it, an op amp that I use as a filter, and an LM386 audio amplifier. A couple of jacks out here on the side, one of them for speaker output and the other for line level audio output if you want to use your own speaker. And in addition to the SPO256, as an option, there's a footprint here for a Votrax SCO1A chip. The SCO1 or SCO1A, much more difficult to find. You could end up spending somewhere between like $100 and $200 for this chip. There is some hoping that there's a guy, Scott Savage, who's working on a modern clone for the SCO1A. Best of luck, Scott. I hope that thing becomes a success next year. And you know, if that actually happens, then it will open up all of these projects that I've been designing to be able to support an SCO1 a Votrax chip. Okay, let's try out the speech synthesizer again. So I've already got fourth program loaded. Let me just show you what that program looks like. Let's see, that was say demo.f and show file. A little bit of it scrolled off, but basically reading and writing the speech synthesizer is very easy. So let's look at this say phone routine. What it does is it goes into a loop of reading port 41 hex until the least significant bit is set. That waits until the speech synthesizer is idle. Then it takes whatever byte is on the stack and it outputs it to port 41 hex. Now I've got a function here called say stack, which will take all of the phonemes that are currently on the stack until it hits an FF, which is my end of word marker. It'll take all those phonemes and it'll say them one by one using say phone. And then we've got a couple functions. Scott was here and Zilog Z8000. Now I did these by manually looking in the list of phonemes and getting their hex, the hex digits that go along with them. So anyway, let's go ahead and try this out. So Scott was here.
Scott was here.
And I'm using this little Radio Shack speaker here. This thing's great because it has an amplifier in it and a volume control on it, which is even more important because it lets me change the volume. Let's try that again.
Scott was here.
And let's do Zilog Z8000.
Zilog Z8000.
And one more time.
Zilog Z8000.
I got that a little bit wrong in the 1000. That's what happens when you try to do it yourself with the phonetic dictionary. Sometimes you get them a little bit off. Now I also wrote a text-to-speech tool just called say. It's a command file. So this is a test. And it uses the Naval Research Laboratory text-to-speech algorithm to convert these words into the phonetic things that you need to send to the speech synthesizer.
This is a test.
And that's actually the phonemes that it sent out. Let's try something a little bit longer. So like, I am a Olivetti M20 computer. So one thing is these things don't always get language properly. It's just a very simple set of rules that tell it how to convert, but let's see what it does.
I am the Olivetti M20 computer.
Okay, it was more or less recognizable. You are listening to my speech synthesizer. What does it do?
You are listening to my speech synthesizer.
Okay, pulled that off, I think. Okay, here is one that I have designed myself. This is a Vinculum VDIP1 board. And this is the Vinculum, this is actually a V2 DIP1 module, which I could get from Mauser at the time. They were out of VDIP ones. So I've got this, and you know, we've got USB thumbstick here that you can just, any old USB thumbstick that's FAT formatted ought to work. And what this does is this Vinculum module here, it implements a microcontroller and it allows you to read and write with a very simple protocol, the FAT64 file system on this flash drive. So we have some tools written by another friend of mine, Glenn Roberts, who did this on the Heathkit H8. He wrote some C programs to copy files on and off of that. So I ported his C programs, and now I have PCOS software that can copy files to and from USB flash drive. That's really pretty useful. I'll put the schematics, the Gerbers, etc. for this online. It's a relatively simple circuit to implement. You just have the VDIP module. You've got some address decoding type stuff, a couple PLDs, and you've got, you know, a buffer for it, voltage regulator for it. Now, back when I did this for the Heathkit H8, I could not get my hands on the VDIP module. So what I did, and I have a separate video on this, is I emulated it with a Raspberry Pi Zero, which is this guy here. And you know, that's what I would use until I got myself a VDEP module. But what happened is I actually liked the Raspberry Pi Zero solution, because this would allow me to basically turn this into network attached storage. So I could have a network storage device implemented on this Raspberry Pi, talk to it as if it was the same as this VDEP module, and be able to copy files on and off of the Raspberry Pi. And that makes it very convenient. I can share an NFS volume with my Windows PC, and I can copy files right off of it. No more sneaker netting things back and forth. So what I did with this particular board is I made it so it simultaneously supports both. You can plug in the VDIP1 or V2DIP1 module over here and have USB. You can plug in a Pi, and you can have the simulated VDIP1 and kind of a network attached storage device. Your choice. Also, it pulls out the serial pins for the Raspberry Pi, so you could actually use this as like a terminal server to hook it up to the board. And we'll see this operating in a minute. Okay, now let's try out the VDEP board. And what I have a USB flash drive inserted in there right now. It's just some random flash drive that's been floating around here for Windows use and such. And there's a set of utilities. There's vdir, vget, vput, vcd that allow you to interact with that USB flash drive. So if we do a vdir, and I have to say my friend Glenn Roberts, he wrote these for the Heathkit H8. I ported them over to Olivetti PCOS. Let's go ahead and do a vdir. It takes a little bit to load the command. But there, now we've just done a list directory off of that USB flash drive, and we could easily do a vget, and we'll just get xmodemr.map, just some random file on this I was using for test purposes, and it should, once the command loads, it should take about 6 seconds or so to transfer that file off of the USB. There we go. Now that was off of the USB. We also have, if you remember from the board, it also has a Raspberry Pi on it which emulates a second VDIP. So that one, I changed the command line. It's now pdir, and we will read what the Raspberry Pi has access to. It's a little bit slower than the USB. Maybe I need to, improve my implementation. And then we could do pcd Olivetti pcd file /Olivetti. And like I say, this is reading off the Raspberry Pi, so you've really got the ability to have a network attached storage with this, because I have this actually hooked up to my Synology. I can read files directly off the Synology. This makes it really easy to transfer stuff. It's a little bit more convenient than Xmodem. Maybe about twice as fast as that Xmodem implementation, so it's not super fast, not as fast as a USB, but this is, like I say, this is coming off the Raspberry Pi. Let's just get a command, pget maze.cmd. And then let's draw a maze. Why not? All right. Okay. In conclusion, I hope you enjoyed this video. I've certainly had some fun getting this computer and upgrading it and learning about it and designing some boards for it. If you can find one of these things, and you can find it for a reasonable price, or you can get it shipped to you, I do say, go ahead and pick it up. It's just an interesting piece of history to have around. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and Sandrail stuff. Bye.